Howdy guys, this is my first YouTube video. Basically I'm just going to walk you through a standard max-min problem. Let's say for example that you have a farmer who's interested in maximizing the total amount of area he can have for say growing crops, and to do that he's got 80 meters of wire in which he creates a rectangular area bordering this river which I've so brilliantly drawn. So let's say he wants to create a rectangular area which I'm about to draw now. Right? And be in mind that he only has 80 meters of wiring, and he doesn't have to wire this side bordering the river. He only needs to worry about these three sides, this one, this one, and this one. In other words, the length of this plus the length of this plus the length of this is going to be equal to 80. Right? Not only that, but because we know it's rectangular, we can say that whatever value this is, let's call it x, we know that this value must also be equal to x. And because we don't know this, we'll just leave it as a variable L. Well, first let's start off with the basics. We know by definition, and by what I just said, that x plus L plus x has got to be equal to 80. Right? This side plus this side plus this side has to be equal to 80 meters. Therefore, we can rearrange to find L. We can go L is then equal to 80 minus 2x. Right? So in other words, we can redraw this. Instead of replacing, we've already managed to replace L, and we can replace it with 80 minus 2x. Next, we want to find the area of this paddock or farming ground, which he's interested in, which I'll call A. Well, we know that the area of a rectangle is the product of both of its sides, so we know that the area is going to be x times L, which is going to be equal to x times by 80 minus 2x. Right? We can expand this out too. We can write that as minus 2x squared plus 80x. That's A. Right, now let's say out of curiosity we wanted to graph this, A versus L. Right? We want to see how the area of this paddock or farming ground changes as x changes. Well, if we were to graph it, keeping A as our y-axis and x, coincidentally, still as our x-axis, then we'll find that we'll get a parabolic relationship. The reason why I know that is because there's an x squared here. It's a degree 2 polynomial, and by definition that means it's a parabola. First of all, we're going to factorize out. Going to be x, and that's going to be minus 40. All I've done is I've factored out a minus 2x, and you can check that I'm right too. If you were to times this out, you'd get the same answer. That'll be minus 2x squared plus 80x. Right? So that's A. As a result, we can now graph this thing if we wanted to. We can just go. Well, how about we try and find the x-intercepts. To find x-intercepts, we plug in A is equal to 0. Therefore, 0 is equal to minus 2x, x minus 40. And here we're left with two different solutions, both of them being unique. One is minus 2x is equal to 0. That's if we were to divide both sides by x minus 40. That's one case. And the other case is x minus 40 is equal to 0. That's if we divided both sides by minus 2x. As a result, we're left with two different solutions, one of them being x is equal to 0, and the other one is x is equal to 40. These are our x-intercepts if we were to graph A versus x. So we know that the parabola looks like this. Now you may be asking, how do you know that it wasn't concave up? Why did you just assume it was concave down? Well, I didn't assume. I worked it out. You know that it's concave down because the coefficient of x squared, which is our highest power, is negative. This shows that the double derivative would be negative, and therefore it would be concave down. I can show that rule to you in another YouTube video if you're still interested. But for now, just accept it. So we know that one intercept is 40, and the other one is 0. Already, you can get a basic intuition for what you think would be the maximum area. Notice how the area gets larger as you get up here. So you'd think that the area maximum would be right here, and you'd be right. I'll just denote that by a max, which is a constant. And that's the value we're trying to find right here, which denotes this bit at the very top. The problem is we need to find the corresponding x value, which will give our maximum area value, and I'll call that x max. Even though it's not the largest x value we can have, it's the x value in which we get the highest area value, right? Now, there are two ways you can do this. One way is realizing that a parabola about its stationary point, this is the stationary point, is completely symmetrical, in which case you could tell that if you just average the two intercepts, you'll be able to get your x max. And obviously 0 plus 40 divided by 2 is just 20, so you can already tell that the maximum of the x max value is going to be equal to 20. However, sometimes the problems aren't this easy, so I should probably do it using first principles and use calculus to prove it. But nonetheless, in this particular example, you could just say that x max is 20 and its corresponding value is the area when you plug in x is equal to 20. Nonetheless, I'll do it the more formulaic way. So first, to calculate this point right here, what we're going to have to do is we're going to have to find dA dx. I'll tell you why in a second. If you find dA dx, which is equal to, let's see, minus 4x plus 80, that's just using this one right here, just differentiating that. Actually, that's a very messy 80, isn't it? 4x plus 80. And when you solve for dA dx is actually, let me just explain what I've done here. dA dx denotes the gradient of our curve at any point x. In other words, if we were interested in, say, this point here, we'll notice that it has a gradient of minus 4x plus 80, right? And more specifically, if you were to point this down to say, I don't know, let's say this was, I don't know, 10, right? Then at this point here, you'd find that it has a tangent which has a gradient of minus 4 times 10 plus 80. Which would be 40. In other words, the gradient of this point right here would be equal to 40. That's calculus in a nutshell. So what we're going to do is we're just going to find the value of x such that dA dx is equal to 0. What that means is I'm going to sub in dA dx is equal to 0 so I can find our stationary point, because we know right here that that the stationary point has a gradient of 0. We know that because the gradient is given by the rise over the run, and for a horizontal line, which is what you'd expect from a stationary point, you'd expect a gradient of 0. So if we solve dA dx is equal to 0, we get minus 4x plus 80 is equal to 0. And if you solve that, you'll get x is equal to 20, right? Sub the minus, get the minus 80 over here, divide by minus 4, and you'll get 20, right? This denotes the x value at which we reach our stationary point. In other words, it's this point right here, x is equal to 20, which is what we discussed before. Now the beauty of finding a stationary point is you know it's going to be either a local maximum or a local minimum. And you can prove whether it's a maximum or a minimum by finding the second derivative. So that's what we're going to do right now. If we find the second derivative, d squared a dx squared, we know that's equal to minus 4, just based off this right here, right, which is less than 0. Therefore, it's going to be concave down. Right? I'll show why in another video, but for now we'll just accept that just if the double derivative is less than 0, that means at that point it's concave down, which means that it's a local maximum. Therefore, local maximum. Right? Which means that at x is equal to 20, right? Sub x is equal to 20 to this formula, and it's still negative because there's no x's in here. Therefore, x is equal to 20 is a local maximum, right? Basically saying, if we sub x is equal to 20 here, which means 20 20, and what would that be? That would be 20 times 2, 40. So 40 here, 20, 20, 40. This would create the largest area we can possibly get. Interesting stuff, huh? So therefore, our dimensions are x, x, L, or otherwise 20, 20, 40, right? This creates a maximum area of 20 times 40 meters squared, which is equal to, what's that, 800 meters squared. Alright, hope you guys like that. Tell me in the comments below if you found this YouTube video a little bit too confusing, I didn't explain anything too well, or tell me conversely if you liked it and you'd like more videos. Cheers guys, bye.